whiff of hay.
Oh.
And so that's why I've sniffled all day, is that I changed my shirt and everything, and it still just is irritating my nose. I can feel the hay that I inhaled tickling my nose. So promise I'm not sick. Promise it's not a symptom. I just swallowed some hay this morning. Okay. Let's share the screen. Yes, thanks, Haley. I wondered if everyone heard me sniffing, if you guys were all going to be immediately afraid that I had a runny nose, which, I mean, I guess technically I do, except that I can tell it's hay. Okay, let's switch back to our screen. Hopefully. Great. Was it at all easier to see the electronic whiteboard on Zoom, or was it still really hard to see what I was writing?
Do you mean just earlier today?
Yeah, just now.
No, you couldn't see it at all.
No.
No.
Okay. All right. Well. Okay. I will maybe try Jeremy's method of just putting the right screen up on the laptop and sharing that, and see if we can start doing that so that you guys who are on Zoom can see what I'm writing here. I kind of liked how he did that. But basically, I was saying that each line of your entry needs to start with a timestamp. And if you guys have questions, you can't get that from my notes on your log submissions, just come see me sometime and we'll go over it. Okay, so we're going to talk about maintenance modification and the kind of temporary mods to systems that you might expect to see as a regular part of maintenance activities on your facilities. We're going to talk about the process for post-maintenance testing and some of the drivers and some of the different responsibilities that the engineers and the operators are going to have for doing this process. And then we're going to talk about our return to operations process and a few definitions of terms that have a very specific meaning when we're talking about maintenance. Okay? So, bypassing an automatic limit response in order to ensure a higher limit response. This is a very standard example of a temporary modification you might make to a system in order to do maintenance testing, or even though our focus is going to be on maintenance because that's most common, a lot of safety systems have a requirement for a monthly or quarterly or yearly test of some of their higher limits. And so this happens a lot. It would be disastrous if in doing this, you never put that lower limit back into service as where you're going to get a reactor to trip, right? Our safety analysis is based on the fact that you as operators are going to get very early warnings of anything that's concerning or anomalous, right? So this scenario, for example, most of the time in our safety analysis report, we have a limit on reactor power. That's one of our primary safety limits. That power corresponds to a temperature that the reactor will be at when the fuel is producing that much power, right? Because we talked about in materials class, one of our major assumptions at all times is we will not melt the fuel cladding, right? That's kind of an ironclad operating principle. Whatever we do, we will not melt the fuel cladding. So therefore, there's a temperature that's its melting point. And so that temperature is here. Our safety limit is going to be here. The area, the temperature where we scram is going to be here. The temperature where you can no longer continue to go up in power and remove rods is here. And the temperature where you get your first alert is down here, right? So each one of those steps is going to give you time to ensure the reactor never gets close to that safety limit, right? But sometimes, to make sure each one of those limits receives a signal, activates like it should, gives you the correct mechanical interlocks and alarms, you have to bypass this lowest level one and then introduce a test signal so you can test that next higher one, and so on and so forth, all the way up your alarm interlock bus. Does that make sense? So to do that, you may do any one of these temporary modifications in order to perform that test or analysis, right? You might lift some jumpers or leads in order to say, I know we're going to get this signal, but let's pretend we didn't. Or I don't care about that signal, I already tested it. I want to see the next one in the series, right? Or you might just remove circuit cards so that whatever's supposed to happen with that logic, you just skip it and skip to the next card, right? You might disable an alarm temporarily in order to see if the alarm isn't received, will the other method of creating an interlock be successful, right? So this would be great if on receipt of a high power alarm or an overheat signal, you get a scram. Okay, you tested the alarm, now disable that alarm and see if it scrams to the signal as well, right? Relief valves. So we have an emergency venting system, and if our relief valve fails, it assures that we never overpressurize our system. But to test it, you have to disable the relief valves in the first place to test that vent, right? So that all of these are getting you into a temporary situation where you can test and maintain whatever you need to, right? You might put strainers or filters in certain areas. You might divert flow. You can work on a piece of equipment without water in it. You might block a drain because you know you're going to have some radioactive material in there that you need to collect and you don't want it to go down the drain. Whatever the case may be, okay? All of these things fall in that category of temporary modification. Temporary shielding is a really unique one because technically you're not making anything worse, right? A lot of these, when you do a temporary mod, you're going to make the reactor response to an accident or operation potentially worse and more risky, right? You're removing some sort of safety feature or protection in order to test a different one. Temporary shielding isn't really like that. You add temporary shielding, well, now you just have more shielding. But the problem is that when your rad protection engineers and radiation safety techs determine where you have to have shielding, you can't move that shielding. So if they have to put in some sort of temporary shielding, all of the operators and personnel in the facility need to know, is this permanent shielding that we have to test and make sure it doesn't have cracks that are allowing some streaming dose through it? Or is this just here temporarily for this particular job? It's been assembled correctly today, and I can verify that before I go do this work, right? What our shielding is for is important. And so we need to know if it's temporary or permanent. So, like we said, almost all of these are related to maintenance and updates, right? This is because if you need to make a permanent system change, which does happen, there's something called the engineering change control or engineering change request process. To change a system, especially one that might have accredited safety function, you have to involve engineering. Because now there's some design aspect, right? It's not just you as an operating saying, this system doesn't work well with this configuration, we need to change this human interface or this alignment. That may be very true, but the engineer has to go in and make sure that the design is compatible with the safety analysis, with the other system interactions, with the materials requirements. So this process is controlled by engineering. The big thing that you will have to resist as operators is using doing temporary modifications as a workaround to avoid this process. Sometimes a system is not high priority, and even though you keep saying, this is an error likely configuration, we need to change this, I've submitted the documentation, please pay attention to my feedback, it may just not be the high priority system for plant management. Maybe you don't have a great engineer on that particular system who has not learned how valuable it is to learn to operate, listen to operators. Maybe there's just not funding for a system that's working its way towards obsolescence anyway, and they want to replace it with something different, and they're just going to let it break, right? Various reasons that sometimes this process is very burdensome, but temporary modifications are not a temporary fix. They're maintenance and update related, okay? This was something that INL was in the process of fixing a history of kind of allowing temporary mods to be workarounds as I was working there. And the system engineering manager did something that made every one of the operators and shift supervisors very angry, which is everyone kept saying, this process is too much paperwork, it's too hard, it takes too long. And so the engineering manager said, okay, well, I'll just make this process even harder, so you have to use the right one. And, you know, made everyone mad because now this quick fix, if it wasn't a maintenance thing, you couldn't get this approved anymore. And so it forced everyone to actually make design changes. But be aware, temp mods are not for working around a problem that needs to be fixed. It's for performing maintenance, doing updates, or dealing with some other very temporary emergent situation, okay?
Another question.
Yeah.
You say there was a temporary modification that your superior told you to do. Would you just do it, or would you be like, no, maybe we could, or just do it?
So,
Whine about it in your mom.
so the first thing I would do, if I didn't think that it should be a temporary mod, like I'm assuming you're implying I think it should be engineering change control. So the first thing I would do is I'd just ask, why aren't we doing an engineering change control? Maybe there's something management knows about an update coming down the road or a change in the work that's coming to a facility that I don't know, that tells them that this will actually be temporary, right? And temporary, we mean less than 6 months. So we could be waiting to order something that's very specialized and won't get here for 4 months. So we do a temp control, temp mod, and then there's a delay in shipping that or manufacturing it. And so we end up having that temp mod for a year, but that means we've only renewed it twice and we have a solution on the way, right? That would be acceptable, even though it's longer than the normal timeline we think, right? So first I'd ask, why aren't we doing change control? Make sure there's not something management knows that I'm not aware of that says that this is the right choice. If it's any answer along the lines of, this is too time consuming or difficult, or the engineer's too busy to work with us, or we just have to get this system up and running to meet our deadlines, I would say, I don't think that this is the appropriate work control. I don't think this is good conduct of ops, and I am happy to work on this process instead of implementing the temporary mod. Have a solution for your management. Don't just be the whiner about safety, because then everyone gets that attitude, right? Be the advocate for why we can do it the safest way, which is I'll be happy to work this process. Which is why operators and engineers having good relationships makes your job a lot easier, right? Because you know you can go to this engineer and say, hey, my boss wanted to do a temp mod, he wants it done yesterday, can we go through this process as quickly as we can, right? And then if you really think that you're still getting pressure to do the wrong thing, all employees in nuclear industry have stop work authority and protection for that kind of whistleblowing. So if you skip your manager and go to the next manager up and say, I think I'm being asked to do something that I don't think is right, There are very specific laws that protect you from losing your job or having negative repercussions in the workplace. So that would be how I manage it. Is assume first, everyone's intending to do the right thing and there's something you don't know. Once you've asked those questions, if that's not the case, then you deal with the safety issue. Does that answer your question?
Doesn't happen often though, does it?
No. I have seen it happen probably 3 or 4 times where an employee felt they were being asked to do something that they did not think was appropriate. Twice, it was just an issue of bad communication between management and the employee. Management had a reason for doing it that way that the employee wasn't aware of, and management respected their questioning and gave them time to review that decision-making process and get on board, and then work was resumed. And it was actually written up by management as a good example of employee questioning attitude that went into their metrics for that. And then twice, it was this management wants it done fast, and this was the most expedient way to do it. And it was technically okay, because this is still an authorized way to have your system, right? Temp mod, you still get approval from the engineer to operate that way. You're just not supposed to use it as a workaround. And the supervisor was actually removed from that position of authority. And the employee was praised for the questioning attitude and standing up for safety. And then the fourth one that I saw happen, it was just a difference of opinion between the supervisor and the engineer, in that case, it was the engineer, on what some definitions were for the changes they were making and whether or not it was permanent. And they went through this whole long, drawn-out difference of opinion process. And as it was taking so long, the manager finally just said, man, it's going to take longer for you and I to work out our issues. I still think you're wrong, but let's just do this because it will be faster than arguing with you. Yeah, there's a saying that I feel is very, very true about engineers. Arguing with an engineer is like mud wrestling with a pig. Eventually you realize that the pig likes it, but you're still both dirty. So engineers really like to argue their point. So in that case, the manager just was like, we'll do it this way. Even though I think I was making the right and safe decision, we'll do it your way because your difference of opinion process is going to take longer than just doing it the other way. And so I didn't actually get to see that one. It wasn't on the system I was assigned to. So I'm not sure who was right, but they eventually didn't do a temp mod. So, okay. Temporary modifications are still reviewed and approved by engineering before maintenance or operations can implement them, okay? They look at the design of the modification. They make sure that it's going to accomplish the purpose that you have for it, whether it's isolating a certain system for testing or putting you in the correct mode for maintenance. And then they're also going to ensure that whatever operations are happening around this temporary mod, that the safety is not jeopardized because a system has been modified to allow for maintenance or testing or updates or whatever, okay? This process is done before installation, before you remove it, and after removal. Before installation, why do we need to get approval before we install a mod?
Obvious reasons, right?
Obvious reasons, yes, such as?
To see if that modification is safe and effective based on somebody's opinion besides your own.
Yeah. To bring in a variety of experts, we're going to ensure that what you're doing is going to do what you think it will, and it's still going to be safe. Why do we have to do this again before we remove it? We're just putting the system back where it was originally, right?
Just to make sure it's like, okay, go back to where it was, change the system, maybe you put something in that changed it.
Okay. to verify that we are actually going back to that same condition and make sure we have approval to do so. Anybody online? Why would we need approval before removing a temporary modification?
Because it was probably put in place for safety or some other reason like that. And so if they're not done using that temporary modification, it'd be unsafe.
Okay, so a temporary modification might be used by multiple people doing maintenance on different parts of the system. That's very much true. But also, and we're going to talk about this in just a minute, before we remove a temporary modification, if we did maintenance or an update and we changed this system, we actually have to verify that the system, when it's back online, can do its credited and intended function. So there is a list, and we'll talk about in just a second, of post-maintenance testing that has to occur after we install it, before we remove it, after we've done all the work, okay? So you can't just say, I'm done putting the system back how it was. You have to say, I did some work. I have to actually prove the system can do its function. Then I can get approval to remove that temporary mod. Why do we need to get approval after we remove the temporary mod?
No idea.
No idea, okay?
To make sure that the original system operates as it did before.
So we're actually going to cover that in our post-maintenance testing before we get to remove it. We're going to verify that here, and then we say, yes, we know that it will. Okay, you can remove that mod. Haley, so the SRO can log it and everyone knows it's safe to use. Yes, part of it is records. We're going to document that we were okay to use it, and then we're going to actually document that it was actually removed. I've seen this multiple times where you finish your post-maintenance testing, you're done, everything's signed, and then if there isn't a step that requires someone to go independently verify that you actually did put it back to its original lineup, we've left things in temporarily modified settings that shouldn't be and weren't recorded as being in a modified setting, okay? So this is to verify that we have our record of putting it back and we actually did it. So we're going to talk about independent verification in just a second as well. Okay.
Apparently, on that, say that you had to reroute some piping and then put it back to the original configuration.
Okay.
The piping that was the temporary, where would you process that to get it out of there if it was contaminated or?
So a lot of times if you're going to need to make that particular modification frequently, like say you need to alter that flow so that you can get at a particular drain that you have to scrape something out of so that you can measure it for your EPA release guidelines once every 6 months, right? Something you have to do periodically. A lot of times they'll just store those tools in a chest in the radioactive area so that they can stay contaminated because you're only going to use them for that. That way you're not recontaminating new material every time you need to make that piping modification. You're not creating new waste, right? It's the same material every time. And you use a consistent tool so that you know every time you're making that measurement, you're doing it the same way. So a lot of times they'll save it. If it was pretty exceptional and you've never done that particular mod before, and you're unlikely to need to do so again, you'd probably just follow your normal radioactive waste guidelines for having generated some waste. But a lot of times they try and store those just in case we used it once, it's been approved, we have a procedure for using it. That's a lot easier to store than to go through the waste discard process and then have to redo it if at some point you need to. Okay, so we talked about this a little bit, right? Before we can remove our temporary mod, we have to ensure the shift supervisor and operators believe the system is ready to perform its intended function. Everybody online, how do we do this? How do we give the shift supervisor and the operators assurance that a system is ready to perform its function, that that maintenance has been done correctly? Yes, Amber, we test it. By performing post-maintenance testing, we are going to verify or prove that the original deficiency has been corrected and or no new deficiencies have been created and that the equipment is ready to return to service. Okay? So maybe your system wasn't deficient and you didn't update. Well, you can't test that a deficiency has been corrected, but you can test that the update did not create any new deficiencies, right? And if you had to replace something or create some sort of maintenance activity, not only do you have to verify that you fixed your problem, you do have to verify that your fix didn't create any new problems, okay? This verification word that we use is really important, okay? You have to actually prove through a documented test that these things are true. So verification means proving, okay? And the way we prove system operability and functionality is this post-maintenance testing process. So in our work control, when we do good ConOps and we use our procedures, there's going to be a maintenance procedure, and then there's going to be a requirement for post-maintenance testing to be written into the procedures for certain types of systems. Every safety system is going to have PMT. Every active, expensive system that you don't want to break is going to have PMT, okay? Operability and functionality. These are the two things that we're concerned with proving, okay? Operability is essentially proving that the system is on and that it can meet whatever operability guidelines the SAR or TSR has, right? So if we have a radiation detector that is credited in our SAR as being able to detect neutrons in the event of an accidental criticality, operability means that that detector is there and on, and that it can detect neutrons, right? That means it's operable. Functionality is that the system does its intended function. So that same radiation detector, we know that it's on and in the right spot, and we know that it detects the right type of radiation, but it's functional when it causes an alarm at the level the TSR specifies, okay? It's on, it's there, it works. It works like it's supposed to, okay? And these words are going to be used, and they seem very similar, but there's slight differences encompassed in what they mean and what you're actually proving and testing in your PMT. Because sometimes things just have to be operable, and by being on and being present, that's all they have to do, right? Others are going to have set points and requirements that they activate at certain limits and levels and alarms that they produce. And that's going to be their functionality. Okay? We've talked about this. Know this. Verifying is actually proving through functional and operability tests. Okay? And a functional test and an operability test are going to have different definitions because we're proving different things, right? The class that's student operating at the ISU reactor right now, we just talked about their NRC definitions for a channel check and a channel test and a channel calibration. Those definitions that they give in the TSR go back to this concept of good conduct of ops in our equipment control, you can check that the system works by flipping the on-off switch, right? You just checked the system. But is it responding to the right level of information? That's going to be a calibration. And our test is going to provide some sort of stimulus to the system to ensure that even though we've checked that it's on and it's calibrated, it actually functions based on our functionality test. Okay. Any questions on that so far? Nope. Okay. So, when we're talking about verification, there's two main forms of it that you will see on your post-maintenance testing. They will typically tell you that you have to have either independent verification or concurrent dual verification. A lot of times in the workplace, these get treated as the same thing. And a lot of times, to save time, shortcuts are taken in the independent verification. So I want you guys to know why these are different so that that's never a problem you have in the workplace, okay? Independent verification is going to be the act of checking. They're going to complete an entire checklist in the work maintenance procedure that tells them to go do their independent verification at a separate time and a separate distance by a separate qualified person. Okay? So what this means is Jennifer is the operator who's going to go verify that the maintenance technician put in a particular modification correctly and that the system is lined up for her to go back to her control room and do a rod drop test. Okay? She goes and she verifies, she does her procedures, she completes her checklist, that step by step everything is great. She has to leave, not be in the area, and wait for another time for another person who is as qualified as she is to go through that same checklist and make sure that that system is how it needs to be, okay? This cannot be someone who watched you do the work. So if Jennifer was doing this while Lynette was waiting for her next tasking, and then Lynette was later asked to be the independent verifier, Lynette would have to say, no, I watched Jennifer do this, I'm not independent. Even if I go back at another time and I'm equally qualified, we didn't have this distance of doing the work. And even if I go back and do it without Jennifer watching me, I watched the work. My independence is contaminated, essentially, okay? If you're training somebody, they don't get to do an independent verification. They can observe, they can see how this all happens. And sometimes, if you have someone who's just completed training doing something, you might add independent verification to their work just until you're confident in them. But it's still not something a training person can do, okay? Essentially, that procedure that you'll use for this independent verification is going to tell you that a given operation or component position conforms with established criteria. So you're not necessarily going to know why this system is being put back in service or taken out, but you will have some documentation that tells you what format it's supposed to be in when you do your independent verification, okay? Also, this is verification. We're proving, we're not modifying. So if your verification finds that the system is not conforming to the established criteria, you don't change it. You don't alter the system. You simply fail the system on its verification, right? And then you guys have to go back and you have to figure out why it wasn't put in the right spot, where the breakdown was. Is it a bad procedure? Was it a sloppy operator? Was it a maintenance technician working too far ahead without a procedure? Where in our ConOps did we end up with the incorrect setting, but you don't change it, okay? Concurrent dual verification, the verifier is going to independently observe or confirm the operation or sometimes the calculation, but they're not physically separated by time and distance. So perhaps you need to go into a radiation area. You can't go in there by yourself, right? We always work in teams in radiation areas, correct? And it's not a Lara to send in a team of 2 to do a action, send those people out, and send 2 more in to get 2 more doses to verify it, right? Unless you really, really, really have to, by regulation, get independent verification of something, that is not an ALARA process, right? So, operator Caden and Lynette will go in, Caden will do the work, and then Lynette, who was standing there at the same time and not distant from Caden, is then going to go through and verify that he did put the right information from the system into the checklist and sign her name as well. Okay, so this happens. What is tempting is for the verifier who sat there and observed to just say, oh, yep, sign it, you're good, without actually checking. You do still have a responsibility to check what the other person is doing, even though you're not doing it at a separate time and distance, okay? And typically, if you're using this concurrent dual verification, it has to have been approved by someone in management, shift supervisor, maybe a worker maintenance lead, that says, yes, it's okay that they're there at the same time and there's no distance between these operations. We're still going to have a good concurrent dual verification. With calculations, this is the one that I saw done wrong the most. They'd watch somebody enter it in the calculator and write down the values in the procedure, right on that checklist. Then they'd sign their name to it. And it turns out that there was an error that the first person made. And then immediately they would get written up for ConOps because that wasn't verification. That was just a signature, right? You didn't actually check and prove that that calculation had been done correctly. You just signed your name because you were there. So, does that make sense? How those are different and why it's important that you understand what you're being asked to do as a verifier with those different types of verification? Exactly. Signing your name to something as an operator means that you're taking responsibility. So don't do that lightly. Okay. So, post-maintenance testing and this verification process should be performed following all corrective maintenance. Corrective maintenance, you guys know what that means?
Fixing a problem.
Yes, there's an actual deficiency and we're going to correct it. Preventative maintenance, you guys know the definition of this?
Maintenance before something breaks.
So something gets break.
Yes, preventing that break on a regular schedule, right? That required a status change of that system structure component. SSC is an acronym that is used all the time. System structure or component, okay? And following troubleshooting activities that might have affected normal functioning of the SSC. Okay, so if by doing some troubleshooting, you were touching some things and adjusting some things, and maybe you affected the normal function by doing that, you're going to do your post-maintenance testing. Okay? For post-maintenance testing, to actually prove that your system has its intended functionality and operability, your actual test needs to be done at conditions that mimic reality, right? You can't drop the flow to half of its normal rate and say, yep, I tested that that valve works, right? That additional flow may change a lot of things about that valve, okay? So making sure whatever parameters you have that are relevant to your SSC, when you do your post-maintenance testing, you're actually mimicking reality. One of the things that we run into a lot is we have to do drop tests with control rods. And so here at the AGN, they take that control rod out of the core and they put it on a rod drop stand. and then they drop it and they time it. And they have to make sure that the drive inserts the rod in a certain amount of time. This is a pretty good way to make sure that student trainees and operators can do it. But having that rod out in a stand that doesn't have the vibrations the same as the core, for example, it doesn't have the same structures nearby that can interact and conflict in the same way, it's not the most representative test for showing reality, right? Luckily, we have very lax requirements in a lot of ways because it's such a super safe and passively safe reactor. But if I was going to say that my method of testing a rod drive drop time at a commercial reactor or ATR was to take that rod out and put it on a test stand that's all by itself and doesn't have several of the same features of the core, it's not a good test, right? Our test stand needs to mimic the conditions that we're testing for as much as possible. Make sense? Okay. Last step is returning to service. And a lot of this is the CONOPS of our documentation, okay? Your shift supervisor has to approve and authorize that system being returned to service. So if there's a status board in your control room that says the system is out of service, OOS, out of service, you can't just change that status without the shift supervisor approving it and authorizing you to do so, okay? Then, once you do return it to service, you have to update your log, right? So your system just came back in service. Any checklists that need that system to be operable, like we talked about, status board. And as control room operators, you're going to need to clear your alarm annunciators. When a signal is received on an annunciator panel in your control room, you're going to get a light that lights up and a super obnoxious verbal alarm sound. I hate the alarm sounds that we used back in the 50s, 60s, whatever they say. The frequency that the sound comes in at just drives me nuts. I hate it. I turn them off immediately. You can silence the audible pretty much immediately and at will. As long as you say alarm received and you've logged it, you can turn off the super annoying noise. And I hope that you all feel the same way as I do about doing that expediently when we're in the simulator, so I don't have to listen to this sound. But all joking aside, you'll receive that audible signal. And even if you clear the audible so that you don't have to listen to it, the annunciator panel is still going to have that light up. You're going to essentially clear or reset the signal going to the light. And if the conditions down that signal path electronically have not changed, and that same signal that something's wrong comes back, the panel's going to relight up and you're going to get the audible again. But if you've changed the circumstances that led to that signal, you have a system that was offline that's now online, when you clear the panel, you have essentially reset the ability to receive that alarm anew if that system goes out of service, right? So you have to clear existing alarms when you put something back in service, especially if it's something that gives you an alarm when it's out of service, because you have to be able to receive this alarm if you're operating and a system you have to have suddenly breaks, right? We took it out of service to do maintenance. You knew you were going to get that alarm. That's part of the process of them telling you they're going to do this temporary mod. Then they put it back in service. They have to tell you have to clear your alarm so you're ready and able to receive that alarm again if it actually goes out of service. Does that make sense? Why we have to do that process? Everybody online, are you following?
Yep, that makes sense.
Okay, great. Any questions about what we covered in that CONOPS with our system control, our PMT?
I have a peripheral question about Laura, but it's not about the election.
Okay, let's do our review questions real quick and then we'll answer your question. So, Why do we use post-maintenance testing at nuclear power plants? Give me a couple of reasons we talked about.
Ensure safety.
Ensure safety,
To prove that what we did worked.
prove that what we did worked. What were the two words that describe how the system works?
Functionality and operability.
Functionality and operability. To give us assurance that we have verified our functionality and operability. If that was a test question, that answer would get you full points. And what does verification mean?
It's like checking to make sure that it's functional and operable.
A little stronger word than checking. What about online? What does verification mean?
Verifying.
Proving it.
Approving.
Proving it actually works through tests. Yep. So verification is proving.
Is that a test question?
It might be.
Write that down.
Okay, Joe, what was your question?
You said that two employees going somewhere and getting a dose and then sending them back to verify is not a LARA, or no, sending two more in to verify is not a LARA. So why would it be that way? I mean, the dose, if you do that, you're getting 4 people dose, not 2.
Right.
Instead of 2 that have more dose. Is there any benefit? What's the benefit?
So safety-wise, if I'm sending in more people to get a dose that they don't have to have, because the 2 people who already had to go in there to do the maintenance can also do the verification, that helps keep my overall dose as low as reasonably achievable, right? Because the time they spend verifying will be less than the time they spend doing the maintenance, right? So they're going to get a very small extra dose versus 2 people who are going to get the whole dose of walking into the area, finding the system, doing the verification, and then leaving, right? They've already found the system. They're already working on it. They can do their verification checklist or log or whatever format we're using for our recording our post-maintenance testing. So essentially it's, do I have to send in 2 additional people at all if I just authorize concurrent verification? Because we have to do the maintenance and we have to do the verification. If I can choose a type that allows only those 2 people to get a dose, I have less dose overall at my facility because I have 2 less people who got a dose at all.
Okay.
Does that make sense?
Well, sure.
And then just work control wise, especially on outages, you might need employees to be able to get a very large percentage of their dose limit on a particular task. And so if you have 2 employees who have gotten no dose because they didn't have to go in and do verification on another job, they can go in and they can perform that needed task. Instead of, if everyone has a little bit, you're going to have to break it up and send one group in and they're going to do part of the work, and you're going to stop and send another group in, right? And that chaining together of work to stay under dose is not as efficient as letting somebody finish a task if it's safe to do so. So work control wise, it's also desirable that on some of the jobs where, hey, this one job that's going to take this few amount of hours for you to do, you're going to get your whole year's limit and you're not going to go into a radiation area the rest of the year. That might be the safest way to do that job rather than trying to chain together people doing certain parts of it. And in commercial power plants especially, that is a consideration because some of the outage jobs you have to do have a very high rad dose field that you're working in.
Sounds good.
Okay. Any other questions online? Okay. All right, guys. Well, that is our lecture for today. We will have some sort of exercise to talk about alarms and limits compliance on a Wednesday. And I will communicate with you tomorrow if that's going to be here, if we use Vince's office again, or if we're in our mock control room.
We have, groups again for that.
It's going to depend on where we are. If we're all in here together, we won't have groups. If we're in the mock control room, I will split you guys into groups because we can't have all of us in there at once. And so we'll split into a group with an RO and SRO, and we'll have a shift supervisor, and we'll go from there. Okay.
Can we do the same groups?
I don't know. I will let you know when I know if we're doing groups. I don't want to plan out groups and then end up saying, hey, just everybody come to the classroom.
Yeah.
All right, guys. See you tomorrow.